Well, I kind of messed up and hit stop recording, so your review is in two separate recordings now. Oh well. So now we're going to continue on number 8. So get the n squared by itself, subtract 4 on both sides, which again you don't have to show that work. You can do it in your head. You get n squared is 90. Square root both sides, and n equals plus or minus the square root of 90. 90 can be broken down, so change it to 9 times 10. Okay. And then you can do the square root of 9, so it'll come out of the radical. The square root of 9 is 3. So my final answer is plus or minus 3 root 10. Okay, which, as you know, you can write the answer is positive 3 root 10 and negative 3 root 10. Okay, hopefully you guys are hanging in there. Now would be a good time to pause the video and work through the next 3 problems on your own, and then start the video again and see if you got them right. I'm going to continue working them out, but you should hit pause right now. Number 9. Subtract 6. 5n squared equals 315. Divide by 5. So n squared equals 315 divided by 5 is 153. Is that right? 315 divided by 5? I feel stupid for this, but duh. Sorry, I am stupid because that didn't seem right. What the heck is wrong with me? Square root both sides. And n equals plus or minus the square root of 63. But 63 can be broken down into 9 times 7. The square root of 9 is 3, so it comes out of the radical. And I get 3 root 7. Number 10 is one of those cases where you might think, oh, there's no answer because there's a negative over here. You can't assume that until after you get the square by itself. So first, I need to isolate the negative 2v squared. So this 2 out here is positive. This negative goes with this 2 in the back. The 2 out front is positive, so I'm going to subtract 2 on both sides, okay, which gives me negative 2v squared equals negative 100. Divide by negative 2 on both sides, v squared equals 50. So it's not a negative on the right side. Therefore, this we can do. There is an answer. Keep on going. Square root both sides, and v equals plus or minus the square root of 50. But 50 can be broken down. 50 can be changed into 25 times 2. And the square root of 25 is 5. So that comes out of the radical. So my final answer is that v equals plus or minus 5 root 2. Or again, positive 5 root 2 and negative 5 root 2. Okay, number 11. Subtract 2 on both sides. And you get 7x squared equals negative 12. Divide by 7, which is not a very pleasant number over there because that's a fraction. I mean, if you want to write it, it's negative 12 sevenths. But it doesn't matter. If I go to square root both sides, you can't take the square root of a negative number. So you stop and you say, no solution. Number 12 looks like it's more complicated, but it really isn't. It's still easy. The square term, if you think of the parentheses as one thing, as one number, the squared thing is already by itself. So we're just going to undo the square by square rooting both sides, just like we did on the other problems. But be careful. Don't forget that a quadratic equation usually has 2 answers. When you square root both sides, the square and square root undo each other. Now I get x minus 1 equals, over here the square root of 16 is plus or minus 4. Okay, it's just like, let's go back to an easier problem if that confuses you. It's just like if I said x squared equals 25, then there are 2 answers to that. X equals plus or minus 5. So when you square root both sides, we just put the plus or minus on one side. So we're doing the same thing here. All right, so back over here, now I got to get x by itself, so I add 1 to both sides. You don't really have to show that work. And I get x equals. If it was a negative 1 on the left side, it's a positive 1 on the right side. So I have a positive 1 plus or minus 4. And now add those together. So x, this represents two answers. X will equal 1 plus 4, which is 5, and 1 minus 4, which is negative 3. If you look back at the original problem before I square rooted it, those will check. Both 5 and negative 3 will work in the original problem. Now would be a good time to pause the recording and work out number 13 on your own. I'm going to go ahead and solve it. Hopefully you paused. I'm going to go ahead and solve it. Square root both sides. Square and square root undo each other, so x plus 5 equals plus or minus 7. Subtract 5 on both sides, which means it'll become a negative on the right side. So x equals negative 5 plus or minus 7. So that means x equals negative 5 plus 7, which is 2, and negative 5 minus 7, 7, 8, 9, 10, 11, 12, which is negative 12. So I have two answers, 2 and negative 12. Okay, last one. Looks the same as the last one. To undo the square, I'll square root both sides. The square and square root cancel each other out. So x plus 1 is going to equal plus or minus the square root of 45. Subtract the 1 on both sides. I said 45 and I wrote 49. What am I thinking? I have an eraser. Woohoo! And let me fix that real quick. Okay, so I subtract 1 on both sides. So I have x equals negative 1 plus or minus the square root of 45. Now I didn't get a chance to say it, or I didn't say it on the last problem. You don't do anything with these because they're not like terms. One has a radical and one doesn't. It's like adding 1 plus x. You can't add those. One has an x and one doesn't. However, for this one, the 45 can be broken down further, so we do need to go ahead and simplify that radical the same way we did for the other ones. The square root of 45 is the same as the square root of 9 times 5. The square root of 9 comes out of the radical. The square root of 9 is 3. So my final answer, if I put it all together, x equals negative 1 plus or minus 3 root 5. Or, written in set notation the way the answer key is, it's negative 1 plus 3 root 5 and negative 1 minus 3 root 5. Okay, so that's it, guys. I hope that went well. I hope you're ready for your quiz. Be calm and good luck.